Hello, everybody, and welcome back. This is Lecture 2 for Critical Thinking. Be sure to see my handout in Canvas Module 1. This outlines the basic concepts and skills I discussed in these first few lectures. Let's review. We're looking for good arguments, and there are only two kinds of good arguments. There are sound arguments, where a sound argument is a valid argument, valid in form, which has all true premises. That's the deductive version of a good argument. Another kind of good argument is a cogent argument. This is an inductive argument that is both strong and has all true or probably true assumptions. We want to be clear in the way we use terms to describe arguments and their components. See this overview on page 53. Recall that arguments are groups of statements. Some groups of statements are not arguments, but what we're going to look at are arguments that are deductive and inductive. And in particular, deductive arguments in this lecture. Now, deductive arguments are either valid in form, that is, truth-preserving, and I'll get to what that is exactly, or invalid. Now, the invalid deductive arguments are going to be bad arguments. We're also going to talk about inductive arguments, and these exist on a continuum of strength with respect to how well the assumptions support the conclusion. So we call them strong or weak. Okay, look at section 1.3, where we distinguish deductive from inductive arguments. If you haven't read this section, you should read it before going through this lecture. So let's contrast deductive and inductive reasoning. Here's an example from the text. Let me say something about it. What we have here are two arguments. Notice the two arguments have the same conclusion. However, each follows from different assumptions. And as it turns out, these arguments are different kinds of arguments. One is deductive, the other inductive. All entertainers are extroverts, and David Letterman is one of those people. David Letterman is an entertainer, and so we may conclude David Letterman is an extrovert. This is going to be deductive. In fact, it's deductive valid, because it guarantees from its form that the conclusion is true. Why is that? How does that work? Well, if it's true that all the entertainers are extroverts, and David Letterman is one of those, whoever David Letterman is, if he's one of those, he's got to be an extrovert. So long as the claim all entertainers are extroverts is true. Just because an argument's valid in form doesn't mean it's a good argument. In fact, I'll show you later, an argument could be valid in form and have all false assumptions. The issue is whether you get the guarantee that the conclusion is true. You get that guarantee when the form is valid, and I'll discuss some of those forms, and all the assumptions are true. Second argument, this is going to be inductive. And notice we lose the guarantee that the conclusion is true, even though it's probably true, given the truth of the assumptions. The vast majority of entertainers are extroverts, which means there's room for people not to be extroverts and entertainers. David Letterman is an entertainer, and so David Letterman is probably an extrovert. Notice, you don't have to know who David Letterman is. You don't even have to know what extroverts are. In fact, you don't even need to know what entertainers are. The idea here is that if this guy is one of those, and all of those, or most of those entertainers are extroverts, then David Letterman is going to be one, or probably will be one as well. All right, how do you tell deductive from inductive? We look for indicator words. When they're not there, and often they are not, you want to look at the strength of the connection between premises and the conclusion. Ask yourself whether the conclusion must necessarily follow or only probably follows. If not, the form is inductive. probably inductive. Here are some guidelines. These are not foolproof. If the conclusion seems necessary, like it can't possibly be false when all of the assumptions are true, then that's a case of deduction. If the conclusion seems probable at best, then that's induction. So there are these two kinds of deductive arguments, valid and invalid. And we're going to focus on the valid ones. And there are two kinds of those. Those are arguments which are sound versus those which are unsound. Real important here, you understand the concept of valid. It's not the ordinary language concept of good, acceptable, credible, worthy of belief. It's a precise logical term. Valid, deductive, means to say an argument is valid deductive is to say that it is impossible for the conclusion to be false when all premises are true. For instance, all actors are robots. Tom Cruise is an actor, therefore Tom Cruise is a robot. You'll notice this pattern. We've been using this pattern in discussions already. This is a pattern that's called modus ponens, that is the method of affirming. For example, all actors are robots. Tom Cruise is an actor, therefore Tom Cruise is a robot. Invalid deductive. An argument is invalid deductive if and only if it's not possible for the conclusion to be false when all premises are true. For example, all actors are robots. Tom Cruise is a robot, therefore Tom Cruise is an actor. You should see that even if the first two claims are true, the premises are true. The conclusion could still be false, right? Think about this. All actors are robots. Now, Tom Cruise is a robot, and so we may conclude Tom Cruise is an actor. Well, that's not how this works. What this is saying of all actors that the thing about them is that they're robots. If Tom Cruise were an actor, then we could say something about Tom Cruise further. Since all actors are robots, Tom Cruise is an actor, and that's what the valid form does. However, in this case, what we are doing is saying Tom Cruise is an actor based on the fact that Tom Cruise is a robot, and we have no legitimate assumption that being a robot makes you an actor, or that all robots are actors. So the claim all actors are robots is going to be a different claim, have a different meaning, have a different truth value than all robots are actors. Well, when is an argument valid in form? It's valid if it has the following property, and there's three ways to describe this. If all the premises are true, the conclusion can't be false. Or you could say it's logically impossible for the premises to be true and the conclusion false. Another way we say this is that the truth of the premises guarantees the truth of the conclusion. Now, the premises don't cause the conclusion to be true, but the premises imply the truth of the conclusion. On page 36 of chapter 1.3 in the text, review the three common valid argument forms or syllogisms. Syllogisms is an old word for kind of argument. Now, you've seen these already in the first discussion. You need to know what a hypothetical syllogism is. You need to know what a disjunctive syllogism is. So far, we've spent some time talking about varieties of hypothetical syllogism. For instance, modus ponens. We'll also talk about something called modus tollens. Some of you are already using that pattern from the worksheet I have for you in Canvas Module 1. Okay, inductive arguments. There are two kinds, strong and weak. Strong inductive, it's strong inductive. An argument is strong inductive if and only if it's improbable that the conclusion is false when all premises are true. For example, in a scientific poll of randomly asked Americans, 87% say that they believe in God. So, most Americans say they believe in God. That's going to be a strong argument because it's really unlikely if the poll was scientific and random and 87% of people polled said they believe in God. It's likely that most Americans will say they believe in God given the statistical reliability and validity of the sample. Now here's another argument. Sounds the same, but it's different. This is a case of a weak inductive argument. And again, we say it's weak inductive if and only if it is not strong. An argument that isn't strong is called weak. And this is one where the conclusion doesn't even follow probably when all premises are true. Take a close look at this. In a scientific poll of randomly asked Americans, 87% say that they believe in God. Conclusion. So most Americans actually believe in God. Now, what I did there was make the conclusion a little bit different. We've got data, the fact that most Americans say they believe in God. And from that, we conclude most Americans actually believe in God. Now you can see a problem here. Unless we can presume that whatever people say they believe is actually what they believe, which we cannot, and that's a flaw in polls to begin with, we really can't conclude probably most Americans actually believe in God at all. We could imagine people, for instance, saying they believe in God and not actually believing in God or having doubts. Again, look at the worksheet I have for you in Module 1. There are some inductive argument forms there. I'm going to go through these briefly here. I'm going to do a more extensive discussion of such arguments in chapters 9, 10, and 13. For now, I summarize 4 typical forms here in this lecture. First up is something that we'll call induction by enumeration. The name doesn't matter so much, although it does tell you how these work. Here's an example of this. All ravens we have ever observed are black, so we may conclude that all ravens are black. Now notice we're moving from all of our observations of ravens to a general claim about all ravens. Now right away you can see a jump from observations to a summary generalization. And you can do that in a strong inductive argument. It doesn't guarantee, it's not a deductive argument, it doesn't guarantee that all ravens are black simply because everyone we've ever seen is. But it's a pretty good reason to think it. And what's at issue here is that we are presuming something in general in any such argument, that if all observed X are Y, if all observed ravens have this property of being black, then probably all X are Y as well. You need that in the argument for it to go through, for it to be strong inductive. Next, there's induction by analogy or comparison. And you're already doing this. You understand this. I'm just going to lay out its logical form here because we're discussing logical form. It's what makes arguments inductive or deductive, namely their logical form. Suppose person A has properties P, Q, R, and S, where the P, Q, R, and the S stand for the properties. And person B has properties P, Q, and R. Well, what about S? Well, we could conclude probably person B also has property S also. Well, why would we do this? Well, we think that the more similar they are, the more likely they have some other property in common. And that's going to be the often unstated but presumed piece of the argument that allows us to say the conclusion follows probably. For example, you're in the school cafeteria and you observe that persons A and B have the following properties. Each has a backpack. They both have a class schedule in hand, a printout. Each of them has our critical thinking course textbook. So you infer, you conclude, you think probably person B, like person A, has property S, namely that person B is a student. So the idea here is you're going to think the person is a student because they share all these other properties. Notice that the conclusion is only likely. Since, for example, the person might be a non-student, say an instructor. I might be sitting in that cafeteria and have all those properties and yet not be a student. Next is statistical induction, and I'm starting to say something about scientific reasoning here. On standard intelligence tests, Asians consistently outscore whites and whites outscore blacks. Thus, whites have higher IQs than blacks and Asians have higher IQs than both whites and blacks. This is an argument that has been made for the past 30 years or so in the psychological literature. Now we can step back a moment and take a close look at the alleged logical relations between the assumptions and the conclusion. This is only an inductive argument. It isn't necessarily true what its conclusion asserts. However, many believe that because of the data collected on standard intelligence tests, that it's a pretty good argument for accepting, probably, the conclusion. Now notice any such argument, any statistical argument assumes that the sample from which you draw your generalization accurately represents the population. So the presumption is this: if the sample accurately represents the population from which it is drawn, then probably whatever is a property of the sample, those people surveyed, tested, IQ tested, it's also going to be a property of the population. See, that's how statistics works. You go from a property of a sample, which is a subset of the whole population, and then say something you think useful about the entire population. Of course, it's not necessarily true. We all know that. But induction allows us to project, to draw conclusions which are not contained in the assumptions. In fact, induction is how we get knowledge. We learn new things. We can make predictions. They aren't necessarily true. Notice that any argument is only as good as its weakest assumption, and it's important here to point this out with this argument. In this case, the main presumptions would fail. They wouldn't be true, for example, if averages of test scores, IQ test scores, were based on unrepresentative or small samples. So the argument stands or falls based on how representative it is, how big the samples are, and more, even if the consensus among investigators is that such tests are not culturally biased, there is this deep vagueness about the concept of intelligence and race, which undermine the value of such generalizations, critics say. Okay, but let's get back to the patterns of reasoning here. I want to separate the logic of the arguments from the truth of the claims. Next is causal induction, and this is going to be reasoning about cause-effect relations, alleged cause and effect relations. So here's one. Many smokers are afflicted by chronic bronchitis, asthma, emphysema, heart disease, mouth and lung cancer. Heavy smokers suffer these problems even more so than do light smokers. Further, non-smokers living with smokers suffer these problems more than non-smokers who do not. So here we're summarizing data, perhaps statistical data, got from inductive reasoning based on observations. Obviously, smoking causes these problems is the conclusion. So the conclusion is smoking causes these problems because we've seen these associations between smoking and these ways people suffer. Big assumption in every argument involving cause and effect, not stated often, but definitely presumed, the arguments won't work unless you presume something like this, is the following. If there is a strong correlation and association between factors X and Y, where X and Y are not accidentally coinciding, and X and Y don't have a common cause, where something's causing both X and Y, but X is not causing Y, and we can be clear that Y is not the cause of X, then we can say probably X is a cause of Y. So you don't just get to call something a cause of something else given a correlation. We all know this. What we can do, though, is start thinking probably X is a cause of Y as long as we are able to eliminate the other more simple explanations. This is sophisticated. I'll get back to this in chapter 10 and 11 on causal reasoning and scientific reasoning. Notice that before we accept any cause-effect relation between variables, say smoking and lung cancer, we need to rule out coincidence and other possible causes. Okay, this argument is going to be deductive, since the conclusion, judges interpret the Constitution and any acts proceeding from it, must be true, if the premises are true. Stating it in standard form, premise, 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 conclusion, where we number the premises and conclusion, shows how the conclusion cannot be false given the truth of the premises. How about this argument? Is it deductive or inductive? Animals that live on plant foods must eat large quantities of vegetation, and this consumes much of their time. Meat eaters, by contrast, have no need to eat so much or so often. Consequently, meat-eating early humans may have had more leisure time available to explore and manipulate their environment. Like lions and leopards, they would have had time to spend lying around and playing. Well, this is inductive since the conclusion, meat-eating early humans had more leisure time available to explore and manipulate their environment, isn't necessarily true, even if the premises are true. Again, framing it in standard form shows the conclusion can be false even if it could be true, given the evidence. We'll work on the exercises at the end of section 1.3. In fact, I recommend doing them all, but in particular, do these that I list here. The more you do and check against the answer key I've posted in Module 1, the better you can become at this. Practice doesn't make you perfect, but it can make you better. On to section 1.4 on validity, soundness, strength, and cogency. We always have to ask whether the conclusion of an argument could be false, even if all the assumptions are actually true. And what I'm describing here is the logic test, the logic condition test. And we're going to talk about it for deductive arguments and inductive arguments. Now, recall that an argument is valid if and only if it's impossible for the conclusion to be false when all of its assumptions are true. For instance, if the conclusion follows from the premises because it's basically contained in the assumptions of the argument. We have to ask whether the form is the same as known valid forms. For example, those forms in the text, section 1.3, and on the worksheet, my worksheet that I have for you in the module. We need to consider counterexamples to the form in order to test argument patterns, and in particular, argument assumptions. And we're going to focus on, we're doing this already in discussions, we're going to focus on conditionals, hypotheticals. Okay, an argument is sound if and only if it is valid plus all assumptions are true. We are focusing here on deductive arguments. Summarizing here, to say an argument is valid is not to say it's true. In fact, we don't say arguments are true or false, claims are true or false. Arguments are valid or invalid, strong or weak. Just because an argument's valid or strong doesn't mean it's any good. That's going to depend upon the form plus whether or not the assumptions are true. Again, there are only two kinds of arguments here, deductive and inductive, and there are only two kinds of good arguments, namely sound and cogent. Now, there are two ways arguments go bad. Again, the goal always is to find good arguments or accept only good arguments, reject the bad ones. And basically, an argument's bad if it fails the logic check or it fails the reality check, the truth condition check. An argument then is bad when it fails the logic check. That is, if it's possible or probable that its conclusion is false, when all of its premises are true. For instance, this one fails the logic check. Jane got straight A's in high school, so Jane will probably get straight A's in college. That's going to be an inductive argument because it's going from her past experience in high school to her likely experience grades in college. So we're moving from the past to the future. Typically, that's an inductive sort of argument, and we're projecting, based on previous observations, some future observations. Of course, we have to wonder how similar high school and college are, and that's going to be the issue with the argument. It's going to be inductive, but it's actually going to be weak. Second way an argument goes bad is if it fails the reality check. That is, if at least one of its assumptions is false or dubious. In fact, if you find one false assumption, then you're done. You don't have to proceed and check all of them. Now, I recommend you do the logic check first. You can save a lot of time if you check the logic. You don't have to check the facts. You don't have to argue with people about what counts as evidence for and against facts, alleged facts. You can just show that the logic doesn't preserve truth, so you don't necessarily get it, even if you grant all the assumptions are true. Here's an argument. Jack completed all of the quizzes because Jack passed the course. And that's a bad argument because we could imagine Jack passing the course and not completing all of the quizzes. You see, you could have a false conclusion. Jack completed all of the quizzes is false. Right? He missed a quiz. The course could be designed in such a way that you could miss a quiz and still pass the course. For instance, this critical thinking course is designed that way. So just because Jack passes the course doesn't mean he did all the quizzes. Okay, I'm going to call this critical thinking skill 5, and this is what we need to do. We need to be able to distinguish deduction from induction. It's important because it tells us how we proceed with testing, examining the argument critically. We have to reconstruct arguments given, simple arguments, ordinary language arguments, charitably. That is, we have to be fair to the person making the argument. We don't want to interpret what they say in such a way that it's easily defeated or that we exaggerate. When more than one interpretation of an argument is possible, we want to interpret it so that the premises provide the strongest support for the conclusion. Imagine if we were giving that argument. In fact, when you restate someone's argument, you should state it as strongly as possible. Because you want to, if you disagree with a conclusion, say because you think an assumption is false, because you want to show them that the argument doesn't lead to the conclusion they think it does, even if all of the things they assume are true. Again, the guidelines here, if the conclusion appears necessary, then it's going to be deduction, and if the conclusion appears probable, then it is induction. The thing about inductive arguments is that their conclusions assert more than what is contained in the premises. That's not a flaw. That's the strength of induction. But conclusions of deductive arguments do not. The thing about a deductive argument is it's not supposed to contain more information than the premises. However, in an inductive argument, this is okay. This is how we're able to talk about the future based on the past. This is how we're able to summarize. This is how we're able to generalize. Of course, our generalizations aren't necessarily true. Of course, generalizations are always simplistic, and yet we need them, we use them. If the conclusion of an argument could be false when all of the premises are true, then the argument is not deductive. The distinction between deduction and induction is important for the logic condition check only. And again, since I advocate that as the first test you do, being able to tell whether an argument is deductive or inductive is important. An argument is bad if it fails the logic check, that is, if it is possible or probable its conclusion is false when all premises are true. Let's look at those arguments again. Jane got straight A's in high school, so Jane will probably get straight A's in college. Or all dogs are mammals, cats are mammals, therefore dogs are cats. This kind of looks like a deductively valid form of argument you're seeing on the worksheet. This is actually not modus ponens or modus tollens, though it kind of looks like them. It is not at all what those arguments require, namely, in the case of modus ponens, that you affirm the antecedent condition so that you may conclude the consequent condition. I'll get to that later, but the idea here is you could imagine that it's true all dogs are mammals. In fact, isn't it? You could imagine that it's true that all cats are mammals, which is the case. But we immediately see that dogs are cats is false. Dogs are not cats, cats are not dogs, no dogs are cats, no cats are dogs. The first argument is going to be inductive, weak because college is more demanding than high school. There's a significant difference between how you perform in college versus how you perform in high school. The second argument is deductive invalid because the conclusion is false, even if all of the premises are true. I'm going to talk about a couple of these deductive arguments from page 46 in the text. Now, you should review each of these. On the chart, you can see that arguments that are deductive are either valid or invalid, and there are four possibilities here. You could have all true premises and a true conclusion. You could have all true premises and a false conclusion. You could have a false premise with a true conclusion. You could have all false premises and a false conclusion. These are the permutations. Now, there are no deductively, what you should focus on is that first column, second row. By definition, there are no deductively valid arguments where the premises are true but the conclusion is false. In fact, that's the recipe for an invalid argument. Maybe we should have a look at that. Let's go over to the right-hand side column. Let's look at an invalid argument. And to see it's invalid, notice that it's got all true premises and a false conclusion. All wines are beverages. Yeah, right? I mean, there's beverages that aren't wine, but here we're talking about wines, not beverages, but wines. The thing about wines, all of them, they are beverages. Second claim, ginger ale is a beverage. Okay, so, ginger ale is not wine. It's a beverage. It's among beverages as well. So we see that wines are beverages and ginger ale is a beverage. So can we conclude that ginger ale is a wine? Of course not. It's something different. Ginger flavored soda. It's not wine. It doesn't contain any fermented spirits. So this is the idea here. You don't want this to happen. If an argument does this, it's automatically bad because of the logical form. You don't get to conclude the conclusion is true just because the assumptions are true, because sometimes bad form allows us to conclude false things from all true conclusions. That's a bad argument. I'll do one more here. It's important to notice this. An argument can be valid in form, but everything it says is false. Well, what good is that? Well, at least we know that the argument passes the logic test. It just fails the second requirement, namely all of its assumptions are true. Take a look at the left column, bottom row, false premises, and a false conclusion. All wines are whiskeys? Yeah, that's not true. No, they're not. Ginger ale is a wine? Already established that it isn't. Conclusion, ginger ale is a whiskey. Okay, so we know that's false. That conclusion is false. Now, look at the logic here. If it were the case, and I know it's not, again, it's a condition. It's a categorical claim, which we can interpret as a conditional. I'll read it this way. If it were the case that all wines are whiskeys, I know it's not, but if it were the case, and if ginger ale was one of those things, the wines, among the wines, would be contained in that set of all of the wines, then ginger ale would automatically be a whiskey. I know it's not, but the point is, were it in that group of things called wines, it would be automatically in the group of things called whiskeys, because wines are going to be a subset of whiskeys according to this. When I say that, let me get clear. When I say all P are Q, what I'm saying is that if something's a P, it's a Q. What I'm saying is there's this big set of things, namely the Qs, and in that set are Ps. Ps are a subset of Qs. There are no Ps that are not Qs, but there are some Qs that are not Ps. Let's look at some inductive arguments now from page 50. Inductive arguments, let's call them strong or weak. Now, they're strong or weak in proportion to how much the evidence supports the conclusion. Let's start with a strong one with true premises and a probably true conclusion. Again, we don't get a necessarily true conclusion in induction. It's unfair, ineffective to say of an inductive argument that its conclusion is not necessarily true. They're never designed to give you necessarily true conclusions. All right. All previous U.S. presidents were older than 40. In fact, I think that's a requirement. But suppose this is true. So we conclude probably the next U.S. president will be older than 40. Now look, the law could change, so it isn't necessarily true that the next U.S. president will be older than 40. But they probably will be in light of all the previous ones are, and the assumption that if previous ones were, then probably the next one will be as well. That's sort of an implicit or unstated, presumed assumption in this argument. So that's going to be actually a good argument because it's strong and it has all probably true assumptions. Let's find a bad one to illustrate something new. Okay, let's go ahead and look at the second column, for the right-hand column, second row. True premise, probably false conclusion. A few U.S. presidents were unmarried. Therefore, probably the next U.S. president will be unmarried. A few is too few. We would need something like most, greater than 50%, to say something like there's a 50% chance the next U.S. president will be unmarried. But we don't have that. Here it says a few. A few could be 1, 2, 3, 4, 5, 6, 7 maybe, but that would still not be enough for us to think that probably the next one will also be unmarried. Now, I know it's true that a few U.S. presidents were unmarried, but that doesn't justify thinking the next one will be. Now, we could change this a little bit and say most U.S. presidents were unmarried. I know that's not true, but suppose it was. Then we can conclude something like probably the next U.S. president will be unmarried in light of the most, this greater proportion of unmarried than married presidents in the past. I've already in the last discussion and in subsequent discussions presented to you the notion of conditionals as implications or hypotheticals. All those terms mean the same thing. It's time to take a closer look at those here. A conditional is false. And we want to know when conditionals are false, because when they're false, we know any argument that features them is bad. So a conditional is false only when its antecedent is true and its consequent is false. That is, the first clause in the claim could be true, but the next clause could be false. That is, the first part implies the second part. When the first part's true, great, but that doesn't mean the second part's true, especially if the second part could be false. I'll get to this. This is called a counterexample test. We test a conditional for truth by thinking of a counterexample to which it shows that it is false. An implication fails when P does not imply Q. If P then Q, that's an implication, that's a conditional. It says on the condition that P is true, so is Q. That is, when P is true and Q is not, the implication fails. The implication, the conditional, the hypothetical, all the same idea here. Different words describe same relation. Example. Suppose someone says, if you love me, then you buy me a diamond ring. Now, hearing that, you can see that it's conditional, namely it says, on the condition that you love me, then this is what happens, you buy me a diamond ring. It's not that love causes a person to buy them a diamond ring, although it might. This is not a claim about what causes something else. This is a claim about an implication. It's a claim about when the first part's true of a conditional, so is the second part. And the question is whether this is always the case. That is, whenever someone loves someone, do they buy them a diamond ring? And I think we can imagine that that's false. If the conditional is ever false, it's not always true. And what conditionals are doing is asserting that whenever the first part of the conditional is true, so is the second part. So you can think of an example which runs counter to the conditional by coming up with an example of someone loving someone and yet not buying them a diamond ring. Well, when? When is this clearly false? Whenever the antecedent is true and the consequent is false, that is, in any case where it's plausible that you both love someone and you do not buy that someone a diamond ring. What would that be like? I don't have the money to buy you a diamond ring. The person doesn't want a diamond ring. They'd rather use that money to have a nice honeymoon, go on a great vacation, invest in a house. So this is what conditionals look like, and they're a little bit confusing for people, and I understand this. It's a new term, though you've been using conditionals for most of your literate life. Think of it this way, you're filling in the blanks. If blank, then blank, where the two blanks are filled in by claims. We call the first one the antecedent claim, the second one the consequent claim. You can also state conditionals this way, and this is interesting. You can intertranslate these. If you put the consequent first, but don't say if, you can say the consequent is true if the antecedent is true. So, bottom line, if you love me, you buy me a diamond ring, is equivalent to saying, You buy me a diamond ring if you love me. Right? I know it doesn't kind of sound that way, but it is. So how do we understand and then test logical implications? Realize that P implies Q means that whenever P is true, Q is also true, always. And so that's its strength and that's its weakness. Conditionals are very powerful. They allow us to draw conclusions necessarily. However, when they're false, they completely defeat the justification of an argument in which they are used. So you want to test an argument's weakest link, weakest logical link, and it's frequently the conditional. And what you want to show is that P does not imply Q. Namely, you can imagine P is true, but Q is not. So you could say if P then Q. Another way to say it is P only if Q. And I think that's actually the best way to read implication statements. It's a little bit easier for me in my brain to imagine the relation between P and Q. What a conditional is actually saying is that Q is necessary for P. P only if Q is logically equivalent to saying P implies Q. It makes us see that P is only sufficient for Q. That is, it's not necessary, but it's one way to get Q. There's other ways to get to Q. There's other things that can be true at the same time Q is true. P doesn't make Q true. And two, that Q is necessary for P. P can't be true without Q also being true. See, this is what an implication is actually saying. P and Q gotta be, always are, true at the same time. And so if you can think of a case of P being true and Q not being true, the conditional is false. That's a counterexample. I said this already in the discussion. You need to review pages 22 through 24 in the Hurley text on conditional statements. I mean, they're also called hypotheticals. And this is why we frequently don't accept hypotheticals, because we can imagine, sure, they could be true, but they also could be false. And so just because someone asserts them doesn't mean we can go ahead and answer whether we think they're true or false, unless we imagine the ways in which the consequent in the conditional could be false, even if the antecedent condition is true. Consider this. If you cheat, you fail the course. This only implies that whoever cheats will fail. It really isn't saying that you're a cheater or you're not a cheater. It's just saying on the condition that someone cheats, they fail the course. Now, of course, that claim would be false. We'd reject that claim if we could imagine a person cheating and actually passing the course. That is, if a person we could imagine a person cheating and not failing. I mean, that could be a person who cheats and gets away with it, right? So that's plausible. So we should reject that conditional, and so any argument that contains it is going to be bad. I mean, cheating implies failing a course. That's one way to fail a course. There's other ways to fail. But failing does not imply cheating. You could fail in ways other than cheating. Two different but valid argument forms using the same conditionals, but different facts and a different true conclusion can be used here to illustrate the point. Argument. If you cheat, then you fail the course. You cheat, so you fail the course. This is modus ponens reasoning. Modus ponens is just Latin for the method of affirming. You're permitted to affirm the antecedent condition, you cheat, and then conclude the consequent, you fail. This is not to be confused with a mistake people make when they affirm the consequent. See, if I said if you cheat, you fail, and then I notice you fail, and then I conclude, so you must have cheated. That would be a mistake. You could fail and not cheat. You could fail and just not understand material, miss tests, whatever. Second example, same conditional. If you cheat, you fail the course. You don't cheat, so you do not fail. That's modus tollens reasoning, and that modus tollens means denying the consequent. So you can deny the consequent and then conclude the denial of the antecedent. Notice how the not works here. If you cheat, you fail. You don't cheat, so you don't fail. So to be clear, you're allowed using a conditional. When you want to reason deductively and produce a valid argument, you're allowed to affirm the antecedent, and you're allowed to deny the consequent. But you're not allowed, you get an invalid argument when you affirm the consequent or deny the antecedent. I'll show you examples of this later. People use conditional statements in arguments all the time, and we tend to just accept the conditionals as true when we shouldn't. Famous example, people say, what doesn't kill me makes me stronger. There's another way to say this: if something doesn't kill me, then it makes me stronger. You could also say, whenever something doesn't kill me, it makes me stronger. Each translation has the same logical relation. It's got this antecedent implying the consequent. The issue, of course, is that that sounds nice, but it's false. We can think of many examples of things that don't kill us and yet leave us weaker, don't make us stronger. For instance, serious COVID infection, cancer, automobile accident, etc. There's a lot of logic going on in this first lecture here, so you can scrub back and forth and take a closer look at these things. Antecedents and consequents are often confused. Some people think you can interchange them, and it's a common mistake. Understandable. The logic is supposed to map onto the way people use language, the way we communicate ideas and relations between thoughts to each other. We're not making this stuff up. It's based on trying to capture the logical relations between thoughts in language, in our heads. What happens when we confuse or reverse the antecedent with the consequent? We end up saying something completely different. For instance, the claim, if X is a cat, then X is a mammal, isn't equivalent to if X is a mammal, then X is a cat, because we can imagine something being a mammal and not a cat. Another example. Focus on the logic here. Don't be confused about whether each claim is true or false, or about the nuances of definition here. I want you to do the logic test first. You can save yourself a lot of work. If X is a racist, then X discriminates on the basis of race. That's an implication of being a racist. Part of the definition of being a racist is that necessarily you're going to be a discriminator on the basis of race. But being a racist implies being a discriminator on the basis of race is not the same thing as saying if you discriminate on the basis of race, then you are a racist. Why is that? Because we can imagine a person discriminate on the basis of race and not being a racist. I mean, unless you think discrimination is identical with being a racist. If you think discriminating on the basis of race is all there is to being a racist, then of course you're going to reject this. But really that's not how we use those terms. Definitely, I think it's fair to say that racism is a form of harmful discrimination. But is it the case that any case of discrimination based on race is harmful? All racists are discriminators on the basis of race, to be sure. But some people who discriminate on the basis of race aren't racists. Because racism also requires unfair or harmful treatment based on race. Whether you intend the harmful treatment or not is irrelevant. Some discrimination is neither more harmful overall nor unfair. For instance, choosing to hire more Black American police officers in a city where they are, say, underrepresented might correct historical or institutional inequities. Of course, this is arguable, but racism and discrimination are not the same, even if both are problematic. Now, again, I do want to focus here on the logic. I don't want to get into the details of each claim's assertion, truth value, whether they're true or false. Okay, let's change this up. I know in the discussion I asked you to give me examples of valid arguments using conditionals, where the conditional could be a premise or the conditional could be a conclusion. And many of you gave nice examples of modus ponens reasoning, modus tollens reasoning, or hypothetical syllogism. A few of you are committing a common mistake, and at this point in learning logic, it's common. Most people make this mistake. In fact, I have to think slowly so that I don't make this mistake myself. It's all too easy to make because this error kind of looks like valid reasoning, but it isn't. So here's an example of an invalid argument using a conditional. I want to illustrate how you could be a discriminator on the basis of race, but not a racist, based on an implication from a conditional and an alleged fact. Notice that the form of this argument is that it's invalid. It doesn't preserve truth. You could get a false conclusion from all true premises, but let me show you. I mean, it kind of looks like a valid modus tollens argument, but it isn't. It's a case of affirming the consequent. I said you can't do that. That's a typical bad reasoning mistake. It's called a fallacy, a formal fallacy. I'll talk more about fallacies in Chapter 3 coming up in the next lecture. Why is this a mistake? Because there's a way for the conclusion to be false when all of the premises are true. Here's an argument. If Spike is a racist, then he discriminates on the basis of race. Okay, right. We accept that. Racism implies discriminating on the basis of race. Claim 2. Spike discriminates on the basis of race. I mean, suppose he does. Suppose it's true. Therefore, conclusion, Spike is a racist. Now again, this is going to be a bad argument. I want you to see this. Why? Because that conclusion could be false even though all assumptions are true. Imagine Spike is a movie director who wants to cast a film about a loving, healthy, and legal relationship between a Black American male and a white American female, and all of the ways their family, friends, and culture disapprove. So it's a film about interpersonal and interracial relations and how people suffer due to racial prejudice. Director Spike definitely discriminates on the basis of race when he interviews and chooses actors. But does this imply necessarily that whomever he chooses for the roles is the result of a racist decision? I don't think so. Again, that's an invalid argument. If you don't see how it's invalid, take a closer look at it until you do. Never criticize an argument by saying, just because the assumptions are true does not mean the conclusion is true. Right? I mean, never criticize an implication. If someone says if A then B and you go, just because A doesn't mean B. Well, right, sure. But it's your job to show that you could have A be true and yet B not be true. It's not enough to say you could be wrong. That doesn't show a person they're wrong. You have to give them an example, a counterexample to the implication, the conditional they assert. I mean, it's trivial to say just because something's assumed doesn't mean its conclusion is true. Right? Suppose someone says, if you love me, you buy me a diamond ring. And you say, just because I love you doesn't mean I buy you a diamond ring. That's really not going to disabuse them of the belief that you should buy them a diamond ring. What you want to do is say, look, I love you, but I can't afford it. And anyway, maybe there's a better way to spend the money. Okay? So that is how you use a counterexample rather than merely denial or rejection of an implication. Such a criticism is ineffective since it amounts to pointing out only that the argument could be bad or that it's not deductively valid. Again, an inductive argument can be good even if it is not deductive. Lots of arguments are not deductive and still good. Also, lots of arguments are deductive and bad. For instance, if they fail to satisfy either the logic condition or the truth condition. See the last lecture on this. An argument can be good if it is inductive and strong. That is, it may have all true premises and a probably true, but not necessarily true conclusion. Now, inductive arguments can never be valid. We don't call them valid. And yet, they're good because the form strongly justifies the conclusion. All right, here's critical thinking skill 7 then. How do you tell whether an argument form is valid? Review here. You have to ask whether the conclusion could be false when all the assumptions are actually true. Recall the definition of valid is that an argument is valid if and only if it is impossible for that conclusion to be false when all of its assumptions are true. And if you've got an argument whose conclusion could be false when all of the assumptions are true, and you can show, yes, all the assumptions are true, and yet you can show the conclusion is false, you show the argument is not valid, invalid. One more example here. Is this argument deductive valid or invalid in form? Of course, green people are bad people. racists are bad people, and all green people are racists. Now, in this one, the conclusion is going to be that green people are bad people. And to be perfectly clear, when a person speaks like that, they mean to say all of them are, not most of them, all of them. This is a deductive argument, not an inductive argument. Now, this argument is actually deductively valid, and it takes a moment to see this. In fact, this is why you have to put an argument in standard form, premise, 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 conclusion, so you can see the relations. Each statement then can be tested for truth. It's deductively valid since the conclusion all green people are bad people has got to be true if all of the premises are true. No escaping this conclusion. Here's how it looks. All racists are bad people. Okay, let's say that's true. All green people are racist. Suppose that's true. I mean, the thing about racist is that they're among the bad people. There are no racists that aren't bad people, this is saying. It's not saying there aren't bad people who are not racists. It's not about that. It's about racists. The argument's about racists. Sorry, that first claim is about racists. Second claim is about green people. The thing about green people is they're racists. So the way to think about this is that green people are a subset of the racists, and racists are a subset of the bad people. There's just no way a green person cannot be a racist, cannot be a bad person. Conclusion, all green people are bad people, follows logically, validly. It is justified by those assumptions just in case they're true. Now, of course, you might disagree with claim 2. That's the truth condition test. But put that to one side. We're testing for validity here. That's the logic condition test. Notice, this argument could be bad even if its form is valid, which it is, because at least one of its premises could be false. Summarizing, valid does not mean good, and we only say arguments are valid. Valid does not mean true. Only claims can be true or false. Valid is that particular term we reserve for evaluating the logical form of arguments, for judging whether or not the argument preserves truth or produces truths. Last example. Here's an argument. Is it strong or weak? You might recognize this from Martin Luther King's letter from a Birmingham jail in April of 1963. He said, "Injustice anywhere is a threat to justice everywhere. We are caught in an inescapable network of mutuality, tied in a single garment of destiny. Whatever affects one directly affects all indirectly." Now, I'm going to call this an inductive strong argument. Since the conclusion, injustice anywhere is a threat to justice everywhere, is likely true when the premises are true. It's not valid, since framing it in standard form shows the conclusion could be false, not necessarily true, even if it is still probably true given the evidence. And so I think the most charitable interpretation of this is that he's not making a deductive argument whose conclusion is necessarily true. He's making an argument for a powerful conclusion, a conclusion that's likely true in light of the assumptions he has, namely that we are inescapably caught in a network of mutuality. We're all tied in some single garment of destiny. He's speaking metaphorically, but he's saying all of our interactions are related. Second claim, whatever affects you directly affects everyone indirectly. I mean, that could be false, but if it's true, and we all are caught up in this mutual network of interaction, then an injustice in one place is going to be a threat to justice everywhere. Inescapable conclusion here. The idea is that where injustice exists, we've seen that injustice can exist among a system where we try to be just, so any injustice is a problem for overall justice. Of course, it's not always the case that injustice in one place means there's a threat to justice everywhere. Perhaps you can contain it. But what he's saying here is it's definitely a concern. And it's probably true. The degree to which there are injustices suffered and endured and not fixed compromises the degree to which we enjoy justice widely. To say an argument's strong is not to say it's good, by the way. Some strong arguments have a false premise. What we want is an argument that's strong in form, inductive, strong, and it has all true or probably true assumptions. That argument we'll call cogent, and that's what cogent means. ultra assumptions plus inductively strong form. Work on the exercises at the end of chapter 1.4. As usual, I think you should do them all and check them all against the answer key that I have for you in the first module. I am going to ask you test questions, quizzes I'm going to ask you questions on quizzes just like these. Is the argument inductive or deductive, valid or invalid, strong or weak? A good way, by the way, to test yourself as to whether you understand these concepts in sections 1.3 and 4, and really all of the text, is to do the true or false questions. In fact, I recommend doing them first. They're nice conceptual questions. Every one you get wrong, you should go back to the text and try to find where they talk about it. The text is that good. Those questions are so well connected to what the author describes and exemplifies in the text that it's unwise, foolish not to work through the examples in the text as the author goes through them. That's it. I'm sorry this is long. I'm going to try to keep these contained in one lecture, though they might be long. You can move back and forth. You have about 2 weeks for each of them. Don't hesitate to ask questions. Talk to you guys again in discussion. This is the end of lecture 2.